morning, ladies and gentlemen. I'll have a spot in this presentation together with Rostya, and Rostya is over there. We will show you some technical background which is behind that. I have to say that I really appreciate that 4G network was down, because right now I've got the best position to continue with, because I will simply just tell you how it works. It's going to be a little bit more technical, as you can tell based on the monospaced font over there. We are more or less programmers with Rostya, so it's going to be a little bit technical. And not so many, not in such a detail. We can talk, of course, later on in the lobby. So I'll talk a little bit about the standardization. That was something we started a little bit less than 2 years ago. And I will talk a little bit about repository, something which is hidden behind for normal user. Of course, the Smart Connect that we introduced on the last summit. Then come something which is really hidden for normal user, which is service channels. I'll talk a little bit more about the mixing of LP standard devices in one network. And last but not least, few words and some video about Autonetwork. So, standardization. It started, as I said, more or less 2 years ago. We've got a few standards. The most well-known is a sensor standard. Today we have about 35 quantities, starting from temperature through humidity, ending with pH or ammonium, whatever you need, it's there. The standardization is based on the standards, and it brings both compatibility and interoperability. Compatibility in terms of that you just simply take some device that measures the temperature, and you don't care. It works, okay? Talk to people from other technologies. This is not usually how it works with other technologies. With IQRF standard, you just take it and it works, because it's compatible in terms of values, in terms of the language, and also in terms of protocol. So it's even interoperable. And at the end of the day, that's the simplicity. The simplicity you saw when Simon was adding the new devices in the network. Just take it, scan, press the button, or use the Smart Connect, and it's working. Yeah, the data are in the same format. The gateway understands it. The app understands it. Your cloud understands it. Very simple. Then comes the IQRF repository. It's a server application that gives the simple RESTful API. The API that gives the gateway, that gives the other applications, the objects, the IQRF objects. The very central object is the product. So you simply just make a query asking for the product. That's, by the way, what the app was doing. Yeah. So it says, for instance, this is the Cooper hardware. It has such a standards, and it can read temperature, this and that. So it's very simple. And last but not least, the very important thing is the drivers. Simon was already touching that. The drivers are small snippets of the code that does the transition between, let's say, machine data to the human readable data. And more or less, it even translates these non-standard quantities. Yeah, non-standard quantities. So we have some devices that give the values that are really not to be never standardized, because they are really specific to the hardware. So these drivers can break it down to the values that make sense for the humans. The Smart Connect. The Smart Connect we introduced last year, released something like half a year ago. And the Smart Connect is a really easy way how to bond a device into the network. It's a buttonless. So compared to the, let's say, original bonding style, you don't have to press anything. The device, by default, is ready to be smart connected. Yeah. So it waits in the low power mode to be smart connected. Compared to the previous bonding, it doesn't have to be in the coordinator proximity. So you can smart connect your device anywhere where your network is reaching. So the smart connecting device could be done in the next room if the network is reaching the next room. It doesn't have to be close to the coordinator anymore. Okay, it's working in the low power mode, so device working on batteries can be simply installed on the wall and waiting dozens of days to be smart connected. Okay, it doesn't have to be. You don't have to have a ladder and pressing the button in the 10 seconds interval. No, it's just there and waiting to be smart connected. You can use, as Simon showed you, QR code or NFC. Both of these devices simply contain such called IQRF code. It can be virtually any device that can store a string of data. So it can be paper, it can be telephone, it can be QR code, so anything. You can even transmit this code over the network. Doesn't matter. Very simple. And it's last but not least, it's secured. Every device has a unique, we call it IBK code, 16-bit unique number that is used to secure the bonding process. So there is no way how the devices can be listened during the bonding process. The next comes something which is hidden behind, and we call it service channel. As you can see, there are 3 service channels, and these service channels are fixed ones for each band that are used for bonding. Okay. Thank you to these service channels, there is no need. The device has to be pre-configured before it's bonded or smart connected. You just take the device and you can bond. If you remember, in the past, you had to take the device, configure it, decide the channel, and go on. As Simon said, there is a magic number 52, which is a default channel, and usually all the older networks are working on the channel 52 because nobody was trying to change the channel. Now it's a different way. You just change the channel on the coordinator, and that channel is to be used by all the nodes that are inherited in the network. You might ask, okay, you guys, you have 3 fixed channels. What about interference? We have a frequency offset of service channels. There is a 50 kilohertz offset of the service channels, and because of the width of our working channels, there is no interference. Okay, so you don't have to care if you have the same channel, working channel, as the service channel. It doesn't matter. By the way, this frequency offset is also used for service mode and for RFPGM, for wireless programming. So even if you are doing a wireless programming or running a service mode on the same channel, the network can work. Mixing standard and LP networks. In the past, you had to decide if your network is going to run in standard mode with only standard devices or LP mode with only LP devices. There was no way how to mix these devices. So the answer is today we have 2 types of devices, 2 types of networks, standard or standard plus LP network. Okay, the type of the network is decided by configuration of the coordinator. So you don't have to upload a specific plugin for coordinator for this or that kind of the network. You just take the coordinator, and by changing the configuration, you decide. Okay? Of course, you have to decide before you build up your network, but it's up to you. As a default, at our gateways, the standard plus LP network is the one that is preset. So you configure the coordinator. Sorry, I'm a little bit offset on my presentation. So you configure the coordinator. When talking about the node, at the node side, you simply decide before you create your node. Usually, there is no need to change the type of the node during its life cycle. Okay, it's usually a battery, so it's LP, or it's running on domains, so it's a standard. So it doesn't make any sense to configure it later on. So you, as a manufacturers, you simply upload the plugin for standard or LP node, and this is it. And then you don't care. Just take the device, put it into network, and it works. Let me spend a few words and a short video with auto networking. Autonetwork is an algorithm based on standard DPA and gateway commands. There is no magic behind. And using the Autonetwork, your network is automatically built. So even the Smart Connect, you don't have to use no buttons, nothing. So it's already built in operating system and DPA. So there is no need of extra code, especially at the node side where the flash is really expensive material, okay? So you don't need any extra byte of your code to support the Autonetwork. If you compare it with the previous version of the Autonetwork, it's a big advantage. You don't need any pre-configuration. You simply just switch on the devices, start Autonetwork, and the Autonetwork will build the network. Later on in the lobby, you can see it. We will show you. You can play with it. Inside, behind the walls, there are three important technologies used. The first one, as you know, is a Smart Connect. It's a special version of the Smart Connect. It's used inside. Then we have a new 4-byte FRC. So you can use it even in your applications. You can it means you can collect 4-byte quantities from the whole network at once. And it uses a special virtual FRC because we have to talk to the devices that are not in the network yet. So we can talk even to devices that are so-called pre-bounded. We provide a sample code for Autonetwork. So there is a really dense code that runs even in the coordinator. We provide a C code that you can run on your gateway in your system. And we are going to release very soon a new version of IQRF IDE that has Autonetwork built in. And I'll show you later on in the video. And let's start the video. So I will then hand over to Rostya. Does it play, please? Or one more click? No, sorry. Is it playing? Yeah. So here you can see the preview of the IQRF IDE with a dedicated screen where you can set up the Autonetwork. It takes about 2 minutes, so you can see how the network is built in. So it works in so-called waves. In each wave, the existing network, in this case only a coordinator, will just join the maximum possible number of nodes that it can hear. As you can see in the first wave, we were incorporating 3 new nodes. They are already discovered. They are enumerated, so you can see there are 2 devices running on domains and 1 is a battery device. Now starts the second wave. In the second wave, it's looking for even more nodes using the existing network. So even these nodes that were joined in the first wave are used to join another new nodes. So you can see there are 3 new nodes. So totally now we have 6 nodes. They are already enumerated. The discovery is done. Now comes the third, I hope the last wave, and the network is going to be finished. As you can see, we specified so-called stop conditions, when to stop. The stop condition was stop if there are 10 nodes, or there were 3 or 2 waves without any new node, or the third condition was the maximum number of waves. So now we've got in total 10 nodes in the network. Now they are to be discovered, as you can see. And at the very end, they are going to be enumerated. And let's see what we've got. We've got 3 devices. One is running on batteries. Another one is going to be on mains. And the 10th, is running on mains. And this is it. So it took about 2 minutes to build up a small network consisting of 2 nodes with 3 zones. If you have a full network we provide, which is 239 nodes, it takes on idle conditions about 35-40 minutes to build the maximum sized network. Okay. As I said, we will show you it in the lobby later on, so you can see. It's the end of my slot. Let me summarize a little bit. We've got, I believe, a really simple deployment of the network. So you don't simply care if your device is running on batteries or on domains. You don't care what is the working channel, okay? You don't care if the device is from that manufacturer or this manufacturer. You just take it, bond it to the network in the way that suits you the best, and you got it. I challenge you, or I encourage you, if you have any other tips how we can make the deployment even easier, talk to us. We will listen and make it even easier. Thank you very much, and let me give the presentation to Rostya.
Hello, everybody. My name is Rostya Špinar, and I work most of my time on the gateway. So I will briefly say something what we have done from last summit to today. I'll also mention when we are at this moment, and also some future plans we have on the gateway. And I have one announcement. So we do the software which run on the gateway, and it's at this moment it's targeted for the Linux devices. We do the Daemon and also the web interface to set up the Daemon configuration, and also to handle the management of IQRF. So last year we had Daemon version 1. At this moment we moved to version 2. So there are a few things we kind of considered for version 2. We wanted to have it modular, so it allows us to add another functionality more easy way. So we don't have to each time rebuild it from the scratch. So that was done. There was also part of the version 2 was integration with IQRF repository. So Daemon now has all the information which are stored in the repository available. How often the information are downloaded from the repository is actually configurable. So you can configure how often this information are downloaded. Then based on the repository drivers, and we kind of provide the API. We extended the API of the gateway for IQRF standard, and also for the function which are available in IDE for the network management. So these are new APIs which were added. We also introduced a new channel for WebSocket, because we felt we had a communication via MQTT ready, and we felt that for maybe local applications the WebSocket is more flexible. We introduced support for the UART, so also some for connection to coordinator. We have SPI, and now we also some gateways have a connection to the coordinator via UART. So that was also a requirement. In Daemon, we take care of the timing, DPA timing. We handle timing for unicast packets, for broadcast, and also for FRC commands. We felt what was important that time we built that was that old application, or the application which were built previously, could still use the new version. So we and run over the new version of version 2. So the version 1 is supported in a version 2 API. And we also now support a new cloud platform from TCP/SEC. So this was the main things, main features which are now incorporated in version 2. There was we wanted to. It was from the beginning was intention was make it open source. This project, those some things were already open source, but we released yesterday. We released complete source code of the project with complete history, and it's available here. And also, we kind of put together the documentation for the Daemon and web application. So the link is below there. So we are at this moment. What are the new features we added? Because we released at the end of the last year, we released version 2.0. And now we are about to release 2.1. So what are the new features? So all the new features which Hynek mentioned, Smart Connect and so on, are already built in and supported. We introduced, based on the projects from IQRF Alliance, we introduced the metadata API, so some additional information can be stored. Shimon already showed you that example. We introduced new service for remove bond. We improved the API slightly for scheduler and make what's more important, and we made it persistent. So after Daemon restarts, the configuration is kept on the gateway. What we are now about to finish is also the upload via SPI. For that, there is actually need to have new hardware, which is now being finalized, not released yet. We are working on that. It's via SPI, and we also support. We also work with Docker. So anybody who works with Docker, we have the support for the Docker. We try to help you with how to run the Daemon in the Docker and also the web interface. So we set up the configuration files for you. It's more easy way. And of course, we already have done that. So there is a source code available. So this is the current version, what we are about to release, and now some future plans. We have, at this moment, Daemon doesn't have any information about the network stored. So we would like to change that and also to work fully with the repository. We need information. We need to have information on the gateway about each device which is in the network and store that locally, so that we can do the things which are needed on the gateway. So we will maintain the topology and device information which is part of the Daemon on the gateway. That's one more important step we need to do. Also, at this moment, when the IP connectivity is down, unfortunately, there is no buffering. But that's what we are about to focus next. We need to handle the security on the WebSocket. At this moment, it's plain WebSocket, no security there, but we have a plan to do that. And there are some more services we would like to work on, such as the Autonetwork. You have seen that in IDE is already about to be released. On the gateway side, we are working on that. We have some prototype, some functionality already done in Autonetwork, but we need to do more testing. We also would like to do the backup restore and over-the-air deployment. And the last thing is there are some discussion that maybe we can also focus on the higher level of API for the complete network, for the IQRF standard devices. So this is the new topic, and we need to discuss more about this, how this can be handled. And we have some partners here who are already working in this area, so maybe we can talk to them, and we will talk to them, and we will work on that together. So I don't have at this moment any live demo here, but I will be in the next room there. So if you are interested to see that in action, I'm there whole day, so you can come over and I can show you that in real. So that's all from the gateway side from me at this moment. Thank you for your attention.